Hello there, this is a video for Algebra 1, Chapter 4, Section 1. And we are going to be learning today how to graph equations that are in specifically the form that we call slope-intercept form. And so on the board we have the actual formula for slope-intercept form, which is y equals mx plus b. This is one of the easiest ways to graph a linear equation. We learned in the previous chapter how to graph equations that were in standard form by using height and divide and x and y intercepts. And this is going to be another way of graphing a linear equation, but it needs to be specifically in y equals mx plus b in order for you to do that. We're going to be in this chapter learning a couple of different forms, and so one of the things that you need to know is when to use which form. And I will tell you right now that slope-intercept form, the use of it is for graphing. Alright, so we have here color-coded slope. That should be familiar to you. We've already learned how to calculate slope in the past. Slope is y2 minus y1 over x2 minus x1. But more specifically, it's rise over run. And so what I have here is to kind of help you know when you have the slope should always be a fraction. If it's not a fraction, then you can make it into a fraction. For example, if I know that my slope is 3, then I can make that into a fraction by putting 3 over 1. Okay? So what I'm saying here is that when you talk about the top number, that's in charge of the rise, and the bottom number is in charge of what we call the run. So if the top number is positive, it means that you go up. If the top number is negative, then you would go down. If the bottom number is positive, you would go to the right. And if the bottom number is negative, you would go to the left. So in this case, since both of my numbers are positive, then that means that I would go up 3 units, and I would go right 1 unit. Okay? But I also want you to be aware that you can also go backwards, because we know that a negative divided by a negative is also a positive. So I could choose to rewrite 3 over 1 as negative 3 over negative 1. And in that case, because the top number is negative, I would go 3 down. And because the bottom number is also negative, I would go left 1. Let's make sure I put my n in there. Down 3. So I wanted to show you that if you start at any given place on a graph and you go up 1, 2, 3 units and right 1, you're going to have a line that looks kind of like this. But I also want to show you that if I went down 3, 1, 2, 3, and then left 1, I would still be on the same line. So that's kind of how that works. And I just wanted to be clear with that because we're about to get into some, graphing, and it's important for you to be able to do this. Okay, so once again, rise is up if it's positive, negative if it's down. Down if it's negative. The run is always positive if you go to the right. And if it's negative, you go to the left. And again, when I have an example up here in front of you, I will show you again how this can be worked out in more detail. So, the other thing that you see in the formula is the B, the pink there. And B is the y-coordinate of what we call the y-intercept. And we've talked about intercepts before. So the y-intercept is the place where the graph crosses the y-axis. So here we have the y-axis. And here's the point, x is 0, y is b, and so here's my line, and this particular line happens to have a negative slope, as you can see from the downward slant on the line. So, we get to our example, and here we go. It says, write an equation in slope-intercept form for the line with a slope of 3/4 and a y-intercept of -2. So right off the bat, we know that there's our slope, and this is the y-coordinate of the y-intercept. That should actually be written like this, 0, -2, and of course our slope is m equals 3/4. So to write the equation, that's really easy. You're going to go y equals, and then your slope is 3/4. I'm going to put 3/4 there. Then comes your variable, so y equals mx plus, and in this case, our y-intercept is negative, so -2. And that's how complicated it is for you to actually write the equation of the line. Y equals 3/4 x minus 2. So now we're going to go to the graphing part. And when you're graphing a line, the very first thing you have to do is always start by plotting the y-intercept first. So we need to find 0, -2 on our graph. So the x-coordinate is 0, so here at the origin when x is 0, and y is -2, so that's right here. And I put a dot there, or a point there, okay? Now, always starting from here. You don't start from the origin anymore. Once you put the y-intercept, which is y is the first step, you start here and you apply the slope, which we said a while ago is 3/4, which is the same thing as -3 divided by -4. They're both the same thing. So I want to show you again how this works. The 3 on top is positive in this case. So that means I'm going to go up 3. Well, we say up 3 from where? Up 3 from -2. So here I'm at -2, so I go up 1, up 2, up 3. And because the bottom number is +4, I'm going to go to the right 4 units. So I'm going to go 1, 2, 3, and right about here, I'm going to put my dot, okay? But I also want to be clear that you can also go backwards, okay? We know that these two are both equivalent. A negative divided by negative is positive, and positive divided by positive is positive. Both of these are positive. So that means that I can also, instead of going up 3 into the right 4, I can go backwards and go down 3, left 4. So I can go down 1, down 2, down 3, right about here, and then 1, 2, 3, 4, right about there. So I can go either direction, and you will notice that either direction that I go, I'm going to end up with the same exact line. Okay, there's my line. And it makes sense that this has a positive slope because the 3/4 was positive. As you look at the graph, it is going upward when you read the graph from left to right. So now I will let you try this one on your own. There's an A and a B, and then we will move on to example number 2. In example number 2, they are asking us to graph this equation, and we actually already know how to graph this using standard form. This is standard form, ax plus by equals c. So we could do the hide and divide thing, but in this case we want to talk all about slope-intercept form. So we want to basically transform this equation, which is currently in standard form, we want to transform it into slope-intercept form. And how we do that is we basically solve for y. Okay, so I'm going to subtract the 3x to both sides, and because it's mx plus b, not b plus mx, we want to make sure that we put the term with the x in it first. So this is -3x, and because there's no plus or negative in front of the 6, Danny, who always gets confused with that kind of stuff, right here, this is a +6. There's no negative in front of it. So that means it's a +6 here. So I'm just going to put the -3x first so that I can have it in the right form, y equals mx plus b. But this is not yet y equals, it's 2y equals. So we have to get rid of the 2 as well. So we divide everything by 2. And now we have y equals, our slope is going to be -3/2 x plus, and 6 divided by 2 is 3 in most countries. So there we go. And now we're pretty much back at the same thing that we just did in the previous example. We want to graph this line. So the y-intercept is going to be 0, 3. So on my graph, I'm going to go to x is 0, y is 1, 2, 3, and put my point there. And then I'm going to apply my slope. And I will do this for you one more time. This is the hardest part, is the slope. So right now we have -3/2. Oftentimes students ask me, well, does the negative go on top or does it go on the bottom? Or does it go on both? It definitely does not go on both. But you can put the negative on the top, or you can put the negative on the bottom. And I'll tell you why. We want our slope to be negative. It is -3/2. If I take a negative divided by a positive, this is still negative. A positive divided by a negative is still negative. If you put the negative on both, then you will end up with a positive slope, and we do not want a positive slope. So your only two options is either put the negative on top or put the negative on the bottom, but you can't put it in both. So if we follow the first one, that tells us that starting from our y-intercept, we can go down 3 because it's negative, and since the 2 is positive, we go right 2 and put our point there. But if I want to go the other direction, I can also use this example, and I can start from my y-intercept and go up 3, 1, 2, 3, and then left 2, which is right about there. Okay, and again, we can see that either direction we go, we end up with our line. And this time, as you read the graph from left to right, the line is going down because it has a negative slope. That should make sense. All right, so that is example 2 for you, and so now we'll have you try these two. Remember to first transform the equations into y equals mx plus b, and then proceed to graph them. Okay, so then we want to talk about constant functions. Believe it or not, when students see constant functions, they get all scared because they're not used to seeing a function with only y in it or only x in it, but these are actually the easiest ones to graph. So a constant function is still considered a slope-intercept form because you could write y equals 0x plus b, but of course we know that 0 times anything is 0, so 0x is 0. So you can simplify that to just y equals b, and of course b represents any number, but it's also the y-intercept. So some characteristics of a constant function are that they are horizontal. When you have y equals a number, they are horizontal. The slope of a horizontal function, we already found out in the last chapter, is 0. And horizontal lines do not cross the x-axis, except for, of course, the case of y equals 0, which actually lies on top of the x-axis. The domain for a constant function is all real numbers, like it is for all linear functions. But the range, unlike linear functions, the range for a constant function is just b, just the y variable, or just the y number. So if this said y equals 2, then the range would be 2. If it said y equals negative 10, then the range would be negative 10. So we want to graph these. So we have one here that are the easiest things to graph. We want to graph y equals negative 3. And based on what we just said in the previous example, I'm just going to very quickly put my coordinate plane up here. And we know that y equals negative 3 is going to be a horizontal line. It's not going to cross the x-axis, and the b value is negative 3, so that's still the y-intercept. So we still know that the y-intercept is negative 3, so I'm going to go negative 1, negative 2, negative 3, right about there. And I am just going to draw a horizontal line that crosses right where y equals negative 3. And there I go. There's no change in y, and we saw in the slope before that when there's no change in y, you get a slope of 0 divided by anything, and of course 0 divided by anything is 0, so my slope is 0, and that's how you graph y equals negative. It's very simple to graph them. Just a horizontal line passing through the b value, and in this case the b value is negative 3, so there's my graph. So now you can graph a and b for do-it-yourself number 3, and then we'll go to our final example, which is right here. Use the, whoa, I forgot a word there, sorry about that. It should say use the information at the left, and the reason why I put at the left in quotations is because I didn't actually, it's in your book and it's at the left in your book, but it's not really at the left in my board. But I only took out the important information from the book about high school sports. It basically says that in 1997, about 2.6 million girls competed in high school sports. So that's why I wrote here, 2.6 million girls competed in high school sports. The number of girls competing in high school sports has increased, that's where I got this from, has increased by an average of 0.06 million per year since 1997. That's pretty much the information that was given. So from that information, we were supposed to write a linear equation to find the number of girls in high school sports after 1997. So we'll get right to it. This is not going to be very hard. Basically, this increase is 0.06 million per year. That actually represents our slope. Okay, so our equation is going to be y equals, and our slope is 0.06 x plus b. And b is the y-intercept, which means at time equal to 0. So we're going to assume, this is talking about after 1997. So 1997, we're going to assume that 1997 is year 0. And so our y-intercept should be 0 comma something. And at year 0 in 1997, according to this information, 2.6 million girls competed in high school sports. So that makes that our y-intercept. So we're going to put plus 2.6. And just like that, you have your equation for part A. And now in part B, they want me to graph it. And of course, our graph is going to be a little bit strange because we're not going to have the exact numbers. It's 2.6. It's going to be a little bit more difficult to graph. But here I have my graph, and it's like 1, 2, 2.5 is in the middle, so 2 point is to be a little bit higher. So right about there is my y-intercept. And my slope is 0.06, and that doesn't look like a fraction to us, but what it does mean is we can write that as 0.06 over 1. Okay, that's basically what we're going to be doing. So this is 2.6. So 0.06 over 1 means that we're going to go up, and actually we can probably, let me see if I can get that into a fraction. All right, so basically it's not gonna make it easier for us to put in a fraction. But I'm going by halves. This is 1/2. I'm sorry. This is 1. So here's a half. Here's 1. So 0.5. We want 0.06. So if you add 0.06 to 2 points, you're going to get 2.66. So we're not going to be very far off. I think I want to go. Yeah. I think what I want to do is, this is the same thing as 0.06, sorry, 0.6 divided by 10. And that's going to be easier for me to do because I'm going to go up 0.6 and I'm already at 0.4 because I'm at 2.6. So if I go up a little bit more, it'll be right about here. And then I want to go to the right 10. So there's like 3, 6, 9, and then 10's right about there. So right about there is my second point. And again, it's not going to be exact, but it should be similar or close. So just try your best. And there's my line. I've graphed it. I went 3, 6, 9, and 10's right about here. So it's a little off, but that's okay. So part B, there we go. There's my graph. Then in part C, it says estimate the number of girls competing in 2017. So we know that when X is 0, that represents 1997. Well, the year 2017 is actually going to be 20 years later. So in this case, X will equal 20. So all we really want to know is what is the Y value when X is 20. So we'll go Y equals 0.06 times 20 plus 2.6. So we're going to get 20 times 0.06, which is 1.2. And then we're going to add 2.6 to that and get 3.8. So we should expect that in the year 2017, there will be 3.8 million girls competing in high school sports. So yay, go girl power. All right, so now you will try this last example. And once you have completed this example, you will have completed your notes for this lesson. And I will see you in class, and thank you for watching.